Hello Zenitarian, welcome back to Zenith Integral Academy. So in today's class we are going to be looking at different block diagram questions, and we are going to be finding their respective transfer function. So let's take a look at this question one. Please make sure you subscribe to my channel and click the bell icon for more notification on my next video. So look at question number one. It states that determine the transfer function of the given block diagram below. Now we have this given block diagram and we want to find a transfer function, and we know that transfer function is the ratio of our output signal all over input signal. Our input signal here is starting from what? From this RS. Sorry, that's our input signal RS all over my output signal of what? CX rather, CS. So this is the relationship that I want to find for this question. So the first thing we need to draw. Now for this question I'm going to be using both analytical and at the same time I'm going to make use of what? Of row reduction to solve the question. So the first thing you need to do is what? Is to draw your diagram. So let's try and draw our diagram. So we have our RS, we have our RS, we have our circle. So let me just draw it first, then we'll continue. So this is the diagram now that I have the diagram already. I've already drew it. Please make sure that the arrows are touching each other. It's touching the diagram, the block of each element. Make sure they are really touching each other and make sure that they are aligned whenever you are doing what? Our block diagram. So now, we've already looked at a case of something similar to this. A case of something similar to this, where I told you that what? We drew something of this nature, that if I have this, we can easily reduce it to what? To this form, and have our transfer function to be G1 all over 1 plus G1 H1. And that thing is what we are also having here now. We have something like this. So instead of me using method of analytical, we can equally use what? Row reduction. So you can say using row reduction method. So using row reduction method. So if I should use my row reduction method, now I'm going to reduce everything from here to give us what? G1 all over 1 plus G1 H1. So I'm going to be having this diagram next. Then this one is going to be G1 all over 1 plus G1 H1. I've reduced everything here. Then we still have this other element of G2 and our output signal of CS. So make sure you join your arrows together. Now we have this. This is what we have left. And since I told us again at the same time that whenever you have what? A two rectangle, what happens? You multiply together. So these two can easily multiply each other. So if they should multiply, this is going to be my next diagram. I will have this G1 all over 1 plus G1 H1 times G2. I will have G1 G2 all over 1 plus G1 H1. Then with my output signal CS. Then with this. So this is what I'm going to be having. So if RS should multiply this, I'm going to be having my output signal CS. So I can easily say that my output signal all over my input signal is equals to G1 G2 all over 1 plus G1 H1. So this is going to be my transfer function. You can see that row reduction is very simple. So let's take a look at another question. So now we have this question 2. We are given our input signal RS, we are given our fourth part element G1 and our circle plus or minus, and we have a feedback element of GH with respect to our output signal C. Similarly, I can easily reduce this using the method of what? Of row reduction method, and just substitute the value since I know what is going to give me already. And if I should reduce just like I said for this, if I should reduce this one, we are going to be having G1 all over what? 1 plus G1 H1, because there's an element here. But if there is no element in this top, just like we have for this, we can easily say 1 all over 1 plus GH1. So I'm going to be having my RS. I have my forward part element of what? Of G. Then this can easily be reduced to something like this. We call this 1 all over 1 plus 1 times GH. then you have our output signal CS. But you know, when you multiply your 1 times GH, it's the same thing as GH. So some people does not use to put there, since 1 is still the same thing as GH. So I can easily write GH, but I just want to show you what we have for those that might be having a problem in getting the aspect. So now I can say RS. Now when you multiply your rectangle together, it gives me this. So I'm going to be having this. G will multiply the 1. I'm going to be averaging times 1 is going to give me G all over 1 plus GH. Then I have my output signal of CS with respect to my input signal. Now, what is transfer function? Is the ratio of our output signal over input signal. If RS is serving as an input signal, multiply this, I'm going to be having CS. So I can say CS all over, automatically my RS is equals to my G all over 1 plus GH. So this is going to be my transfer function for that block diagram. Now I use the method of row reduction. What I just use here is row, we call it row reduction for these two. So let me try and solve this one using analytical method. You will see that we are going to be having the same answer. So now I've redrawn the diagram, so I want to use the method of analytical method now. And analytical method, that's why I told you that you can use some variables to denote your output signal. Now if RS should multiply my G is going to give me a corresponding output signal of A. Now look at this feedback element that we have, which is GH. It is actually coming from where? It is coming from CS. And if CS should multiply this rectangle, since I told you that for a rectangle we multiply, is going to give me an output signal of what? Let me call it B. Now plus of A minus of B is going to give me an output signal of what? CS. So this is what I'm going to be having. So let's do that. So I can say my A now is equals to, for me to have A, RS is serving as input signal, will multiply G to give me this. So I can say A equals to GRS. Let me call this my equation 1. Now similarly, for me to have B, the GH is a what? Is a feedback loop element. Look at the arrow coming from what? CS. So if we should multiply GH, I'm going to be having B. So I can say B is equals to CS and what? And my GH. You can rearrange this. G is supposed to come before this, but no problem. So now for me now to have plus of A minus of B is going to give me my output signal CS. So I can say CS is equals to A minus what? Minus B. And that's same thing as, what is my A? My A is what? GRS minus, what is my B? GHCS as CS. So if I should collect similar terms and bring my CS to this, I'm going to be having CS plus GHCS to be equals to GRS. So you factorize and bring out the CS that is common, it will give us 1 plus GH is equals to GRS. And what's my transfer function? Output signal over, if your RS should come down, is going to give me what? I have ordinary G all over 1 plus what? GH. You can see that I'm still having the same what? The same answer. G all over 1 plus GH, G all over 1 plus what? GH. So any method that you understand, that's what you use. So let's go to another question. Thank you. Follow me in my next video for more questions on it.